Sure ji. Assalamu alaikum. So let's start with our discussion on data representation. Okay. There are a few data types that we study in AS level. The first one is binary, right? That is something that you have studied even in your O levels computer science, right? The other one is denary, right? So what we are writing down over here are different representations to represent quantities or numbers in different systems. Denary is the one that we use in our daily life. That basically includes numbers from 0 till 9. Okay, that's denary number system. It is a base 10 number system, right? Because it has 10 different sort of options to pick the number from 0 till 9. Those are 10 numbers, right? So it is a base 10 number. Binary just has 0 and 1, right? So binary is a base 2 number system. Next we have hexadecimal number system. Okay, now hexadecimal is a base 16 number system. It starts from 0 and it's all normal till 9th, and after 9th we have, instead of 10 we have A, instead of 11 we have B, instead of 12 we have C, instead of 13 we have D, instead of 14 we have E, and instead of 15 we have F. So there are 15 different options to choose from in hexadecimal. Hence it is a base 16 numbers. Okay, so from starting from 0 going all up till to F, that gives you a variation of 16 different numbers. Okay, all right. Now what about the fourth system that we study in A levels? The fourth one is BCD system. BCD stands for binary coded decimal, or BCD for short. Okay, now binary coded decimal is a very special um, type of number system. It only has 0 till 9 numbers, but what we do with binary coded decimal numbers is basically, let's say if I had to represent 42. Okay, so it basically breaks down 4 and 2 into two parts. Okay, and it represents 4 like this. In binary it represents 4 like this: 0 0 1 0. Okay, and for 2 it says, and for 2 we have 0 1 0 0. Okay, so it's like the binary representation of 4 and 2 separately, rather than having one single representation of 8 bits of the entire 42 number. So in binary the same 42 would have been represented, let's say like this, right? So in binary we have 1 2 4 8 16 32 64 and so on, right? And 128, that's the last number that we have over there, right? So we simply place ones and zeros, and their sum should amount to 42, right? So the closest number that we can get from 42 is 32, right? And the next one that we should pick is, let's say, 8, right? That gives us 40, right? And then we have then we should place all a 1 over here as well. For the rest of them we'll just place 0 beneath them. Okay, so yeah, that would have been the binary representation of this same number 42. But in BCD, so this is the BCD system. Okay, and this is the binary system representation of 42. So what BCD does is basically it breaks down the entire number into its digits, and it converts those digits into 4-bit binary representation, right? So each number is represented as a 4-bit binary representation. On the other hand, if you had to convert this 42 into pure into proper binary number, then the entire number 42 would be represented as a single representation in binary, which is which I've shown you over here. Okay. All right. So these are the 4 representations that we learned in AS level. Now let's dig deeper. Let's talk about conversions between these. But before doing conversions, I'll also briefly talk about the uses of all these 4 representations. Okay. So let's talk about the uses of these. As far as the binary is concerned, binary is basically, you can say, it's the principal grammar of the computer, right? That's what the machine actually processes. That's what the machine actually understands, right? So binary number system is basically the machine code. Okay, binary system is the machine code. So this is for the machine itself that we use binary numbers. So binary system is the machine code. As far as the binary is concerned, of course, we what are computers for? We make computers for processing our own information, right? And our own number system is actually just the binary number system, right? So if you want to, represent some basic quantities, we need to have a format which is understandable by humans, right? So binary number system is the one that we use in our normal life. Okay, so it is the natural number system. Okay, and as far as the hexadecimal number system is concerned, and we will dig deeper into this, but hexadecimal number systems are really useful when you have to represent a number that is large enough, but you want to represent it in a more let's say concise manner. Okay, so in order to, if you want to do that, you make use of hexadecimal number system. One very common use of hexadecimal number system is let's say in representing IP and MAC addresses sometimes. Okay, but of course this is just a few examples. We have many more examples, many more use cases of hexadecimal systems. Okay, after hexadecimal system we had the BCD, or the binary coded decimal system, right? Now binary coded system, decimal system, we use it in electronic devices to represent number accurately. We will dig deeper into this topic, why are BCDs a good option in electronic devices. So for example, in a calculator, it might be, in order to represent the numbers on it, you might be making use of BCD system in order to represent numbers in that. Now why is this so useful? We'll talk about that. We'll go into that deeply once we properly understand about the conversions in BCD and all that. Okay, but this was it. I just wanted to, right now I just wanted to introduce you to all the number systems that are involved and where do all these 4 number systems are used. So the first one is binary, second one is denary, third one is hexadecimal, and the fourth one is binary coded system. Okay, now in the next video I'll talk about how to convert between each of these. Okay, that will be, some of it would be a refresher, of course, because it is some part of it is also done in O levels, but we'll basically be reviewing that, and yeah, and there is and after that we'll take the topic even forward from there. Okay.